Hello. In this video, we'll be doing a demonstration of how server-side request forgery or SSRF attack plays out in AWS. We'll be deploying an intentionally vulnerable web application on EC2 using an open source version of buggy web application. And we will be then looking to see how we can exploit this for SSRF. And then we'll have another video, which I will link here later on, which talks about the infrastructure that's needed to defend against this attack using AWS Web Application Firewall. So watch out for that video as well. Now, this is just one example of how SSRF happens on AWS. So don't think that's the only way it happens, but hopefully this helps you in understanding the vulnerability and some possible options to defend against it. So what is SSRF? SSRF is a security vulnerability where an attacker manipulates the functionality of a server and it makes the server do unintentional stuff like reaching out to a network resource, which it's not the functionality of that web application to do. So in the case of AWS and the specific vulnerability that we are looking to exploit here is the access that EC2 instances have to this EC2 instance metadata server, and this metadata server stores important credentials that are used by the EC2 to access AWS resources. Now, what the attacker is trying to do in this attack is it's trying to manipulate the web application because of the intentional vulnerabilities that we are putting into this web application, and it's making the web application to reach out to this server, grabbing those credentials and returning as an output of that web application. Okay, so in this first part of the lab, we will be creating the vulnerable web application in AWS, which involves deploying an EC2 instance, and we're using Windows for this. Uh, so for that, we need a VPC. So let's create a VPC where the EC2 would be housed. This VPC we will be giving the name of CSM and using two public subnets within this VPC. And the reason for using public subnets is because we want to RDP into this Windows instance from our laptop and deploy the vulnerable web application. Plus, at the same time, we also want to mimic what attacker does in accessing and exploiting this vulnerability. So yeah, this VPC would have two subnets, two public subnets, and let's go ahead and create this VPC. With the VPC created, I'm gonna copy some of the ID of the VPC, and I'm also going to copy the subnets ID so that I can use this information to create the other resources that are needed for the EC2 instance. And I have stored these IDs in my terminal to be accessed later. Now I'm going to create the security group that will be attached to the EC2 instance. So this is the AWS CLI command for that, and we'll be allowing web and RDP access to the security group. I will just copy it to a local variable here. And the next thing that we want to do is figure out the IP address of this machine, which will be used for RDP and web access to the EC2 instance. And I would also have to make sure this IP address is part of the security group. So the commands to add the security group is authorize security group ingress. And as you can see, I'm providing the SG ID, the group ID, and the ports that I have provided here is port 80 for web access, and I'm allowing it from my IP address and also from local. And then I'm also allowing RDP access from my laptop as well. So let's run these commands. With that, the ingress is now created for this security group. All right, next up, we are going to attach a role to the EC2 instance, and we're going to run the create role command. We are going to create the S3 access role with the assume role policy that allows the EC2 to be able to assume this role. Now, this is needed because this is the role which we'll be using to extract the credentials from the metadata server. So this is for the SSRF attack, and we're also attaching the S3 full access policy. Again, this is just for mimicking purposes. This is not needed for the functionality of the web app. So with that, the role is created, and just remember this name S3 access role because this would show up when we do the SSRF attack. We will also be creating the instance profile. This is needed for the role to be attached to the EC2 instance, and then we'll be attaching the instance profile to the role. With those two, then the next thing that we have to do is we have to create a key pair for accessing the EC2 instance. So this key pair will be called EC2 key, and this will be stored locally in my command line. And then when I'm going to connect to the EC2 instance, I will be using this key. So now finally, we are ready to run our EC2 instance using the run instances command. This is the AMI for Windows Server 2022. And we have the EC2 key that we have created, the security group, the subnet ID, and the IAM role attached to this EC2 instance. The important thing to note here is this option, which disables the HTTP tokens. Now, this is the only reason why we are able to test this vulnerability out, because this kind of makes the EC2 instance vulnerable to the SSRF attack. The history behind it is that 3 or 4 years back, when this vulnerability was first discovered with capital One, um, this wasn't an option that AWS provided, and so the metadata server did not have any protections against SSRF attack. Using these tokens, now if you ask if those tokens are now enabled, if you ask the server for credentials, the EC2 instance will be prompted for a token. So if you don't have the token, you would not be able to get the credentials. So long story short, this is the vulnerability that we are intentionally inducing in this EC2 instance for the SSRF attack to be successful. And with that, let's run this command and see if our instance comes up. So the command is run successfully, and we have our EC2 instance ID here. The status still shows pending, but let's give it a minute and try again. I'm going to, in the meantime, store the instance ID locally, and let's run the instance describe instances command to see the status. Still shows as pending. If we run the same command again, hopefully we should see the EC2 instance running now. So yeah, there you go. The instance is running. And now comes the interesting part of the demo, where we are going to install the vulnerable web application on this EC2 instance. So let's go ahead in the EC2 instance console and copy the public IP address of my EC2 instance. Um, so it's right here, and what we need to do is copy it and try to get the credentials for this EC2 as well. So the way you get credentials for a Windows instance is you click on this connect tab, and then you click on the get password, and you upload the private key that we initially created, which is this one, ec2key.pem. And the console will then give you the decrypted password that you can then use in your local RDP client and get administrator access into this EC2 instance. So I have this RDP client opened up in Mac. I'm going to paste the public IP address, click on connect to an admin session, and then click on connect, put the username as administrator and the password that I copied from the AWS console, and then I will click on continue. So with that, my connection to this remote Windows instance would start. This new instance would start rebooting, but reboot with the basic configurations which the AWS AMI provides. And we will then go to the next step of installing the vulnerable application on this EC2 instance. So I'm not going to go through the exact steps on how the vulnerable web application would be installed, but I will be using the XAMPP server, as you can see on my screen. And the version of the vulnerable application that I will be using is the open source code for buggy web application, which is right here on your screen. Now, this is an intentionally vulnerable application. So when you deploy it, you would see a ton of vulnerabilities available for you to debug by default. So I'm going to use one of the vulnerabilities in this page and show how SSRF could be exploited for that page. So, and if you go to this page, you can find specific instructions on how to install this. So for your particular, use case. But as I said, I'm not going to go through the exact steps here, but I'm going to show you once the install is done on this remote machine. So I'm in the local host, the installation is done, and in the local host, I've gone to the login.php page. These are the default credentials for this web app. And once you go to this page, you can see there are like the ton of vulnerabilities here available for you to exploit and test out. So till this point, we have installed the buggy web application on our EC2 instance, and we have made this EC2 instance accessible on port 80 as well as RDP from our laptop. So we already did the RDP route. Let's try to access this over port 80 now. So I've gone to this public IP address, which is of the EC2, and I've tried to access the BWAP page, and see it's working over public IP address, right? So now I can see all the list of vulnerabilities that this page provides, right? And as I said, there are a ton of vulnerabilities. So if you are trying to experiment something new, please go ahead and use this website. But the vulnerability that we are going to look at specifically is in this page, which is rlfi.pht, or the remote and local file inclusion page. Now, once I go to this page, I see that they're asking us to select a language, and then based on the language, they are redirecting us to a particular PHP page. And then this is the really interesting part with SSRF, is that this is another network location. And if possibly we change this and copy something like this, which is the location of the metadata server, we can then ask this server to actually reach out to the metadata server and try to fetch details there. So let's see what happens when we do that. So we were actually denied by the XAMPP server from doing this. And so at this point, we will introduce another vulnerability in our web application. So I am now back to my Windows EC2 machine, and I'm going to edit the configuration in the PHP configuration file within the XAMPP server. The exact configuration we are going to update is that we're going to change the allow URL include parameter, and instead of calling it off, we will now call it on. Saving this file and restarting the server, we'll go back again to our web application um, and try to do the same thing again. Try to reach out to the metadata server, and let's see what happens now. Okay, great. So now we are able to reach out to the metadata server, and we see the same role, S3 access role, which we attached to the EC2 instance before. So we know this is working. So what happens if we go to this path of the metadata server, which we have right now access to security credentials, and copy this role over to that path? Um, let's see what happens. Well, we now have the credentials for this role attached here in this very output. So we have the access key ID, the secret access key, as well as the expiration date for this credential. So we have successfully conducted the SSRF attack using this vulnerable web application.